Alright? Okay, agenda for the day. Just want to point out again, this is another assignment paper, MCQs, okay? Take one each. Please complete these MCQs by class next week again. I want to give out the answers for the previous MCQ assignment that I did last week. And then I want to kickstart revision with acids and bases. Okay? Anyway, ready? Can you take up this MCQ, Adam? I want to give out the answers and go through. Okay, question 1, Canada. 2, Canada. 3, Bombay. 4, Australia. 5, Australia. 6, Canada. 7, Denmark. 8, Bombay. 9, Bombay. 10, Australia. 11, Australia. 12, Bombay. 13, Australia. 14, Canada. 15, Australia. 16, Canada. 17, Denmark. 18, Denmark. 19, Canada. 20, Bombay. 21, Denmark. 22, Bombay. 23, Bombay. 24, Canada. 25, Denmark. 26, Canada. 27, Denmark. 28, Australia. 29, Bombay. 30, Denmark. 31, Denmark. 32, Australia. 33, Denmark. 34, Canada. 35, Denmark. 36, Bombay. 37, Denmark. 38, Canada. 39, Denmark. 40, Denmark. Okay, come, let's go through. Question 1 to 3. Anybody need me to go through question 1 to 3? No. 4 to 6. 4 to 6. No. 7 to 9. 7 to 9. No. 10 to 12. 10 to 12. 11. So notice how these particles, you should know particles consist of protons, neutrons, and electrons. Do you agree protons have a relative charge of +1? Electrons have a relative charge of -1. So it means that protons must deviate towards your negative electrode, right? Agree? So straight away I know B is wrong, okay? My D also wrong. B and D are wrong. C is also wrong. Do you know why? Because protons, right? If I were to have here a beam, protons, this is actually my positive terminal, my negative terminal. Do you agree the protons must actually deviate towards the positive? Alright, but your BCD doesn't show that one. Electrons should deviate towards this positive electrode. Neutrons are neutral, so it actually just moves forward because no charge. Okay, answer is A. 12. Notice how barium, if you look in your periodic table, do you see barium is in group 2? So group 2, right, alright, must have charge of 2+, right? When you lose electrons, isn't that your electrons must be on the right hand side? Straight away I know A is wrong because they only lose 1 electron. Okay, B is correct. Your C, there's no such thing as Ba2 because it's a metal. Think about potassium, sodium, magnesium, you always write them as just the element alone. D is trying to gain electrons to form barium, not formation of an ion. Ion has charge, so that's why B is the only answer. 13 to 14, 15 to 17, 18 to 20, 20. Element X found to have 3 naturally occurring isotopes. Isotopes you all should know, same number of protons and electrons, different number of neutrons. They say average atomic mass was calculated to be 197.1. What is true in the natural abundance? Let's see. All isotopes they say has equal natural abundance. That means they are equal percentage, which makes Let's see whether it has sense. If I want equal percentage, that means it's 1 over 3, right? Let's see whether the AR, okay, is the same if you use 1 over 3 for option A. So, in other words, 1 over 3 times your this 197 plus 1 over 3 times 198 plus 1 over 3 times 199. If we type into your calculator, let's see where the AR will be 197.1 first. So again, let's see, plus 1 over 3 times 198 plus 1 over 3 times my 199. So I get 198 exactly. 198 is not 197.1. So A is wrong. Again, they say higher proportion. Let's see. To be honest, again, higher proportion of 197 compared to 198 and 199. It does make sense. Do you know why? Idea if I have higher proportion compared to both of them. Meaning, do you see your AR is 197.1? Do the math. It must be closer, or you have majority percentage. That means about 80, maybe 80% of your isotopes is 197, right? Agree? That's why you can have an AR, which is the average mass of 197.1. You understand? If you have larger proportion of your 198 and 199, wouldn't the AR be closer to that value? You know what I'm talking about? Don't know, huh? You do your math here. This is math here. Okay, so let's say we use arbitrary, because I say higher percentage. I'm going to give you an example. I don't know what's the value. But let's say we say 80%, because it's higher proportion than the others. 80%, because this is what higher proportion means. If I have, let's say, 10% of this and 10% of the other, doesn't matter. The idea is just higher proportion. You type into your calculator, your value will be closer to 197 or closer to this two. Okay, I do the quick one. 0.8 times 197, 0.1 times 198 plus 0.1 times 199. Do you see I get what, about 197.3? Something like that. But the idea, do you see, is closer to this value. If you have a larger percentage of these two, wouldn't it be closer to 198 and 199? That's what I'm trying to say. That's why the answer is should be B. Clear? 21 to 22. No. 23 to 24. No. 25 to 26. No. 27 to 28. 27. Which one following could be solution X? Notice how your solution X, they say time taken for this to react is 20 seconds. Means reaction is very fast, right? They say this solution X was added into sodium iodide. Okay, we already learned that, again, the highest from lowest to highest reactivity. So idea is, if I were to tell you, this is actually in your group 17. So question, Anna, group 17, do you gain or lose electrons? You lose electrons, you sure? 7 valence electron. Rather you will gain how many? 1, right? I will just draw out for you briefly. If I were to have, let's say, your chlorine. Chlorine looks like this. Because it's 2.8.7. Agree? Okay. You know what? I have to draw fluorine as well. Fluorine, you should know, is 2.7, right? If I were to draw fluorine, 2.7 will look something like that. And then chlorine is 2.8.7. If I draw chlorine, chlorine will look something like this. Because we have an additional, right? And then I just draw up the bromine, you get the gist. 2.8.7. So bromine, you will get, again, something like that. So what do you realize about the valence electrons? And further and further away or nearer and nearer to the nucleus? Further and further away, right? If it's further and further away, do you think it's easier to gain an electron or more difficult to gain an electron? Think about this, Do you know nucleus is positive? Because of protons? You want to gain an electron. You think about this. Distance between your valence electron shell and the positive nucleus. Isn't it getting further and further apart? Will the electrostatic force of attraction become stronger or weaker? It's like your magnet becoming further and further. Weaker, right? Is it easier or more difficult to gain an electron?
Difficult.
So the reactivity is going to decrease. But they want the fastest, right? So which one will I rather choose? The one which is chlorine. Anything that is smallest atomic size. Which is chlorine. They don't have fluorine, right? Wait, they have fluorine. Oh, yes. So answer is fluorine. Understand?
Yeah.
28 to 29.
28.
28. No, this is how same thing. You should know the color. So if I were to have, they say solution X was added to sodium iodide. By the way, you should know iodine X is a solid RTP. So if I were to have fluorine, okay, bubble into sodium iodide, they say they will displace, I'll just give you first. I'll form sodium fluoride and then your iodine. Iodine, right, can be aqueous iodine. If I tell you it's aqueous iodine, can you now tell me what would the color of the solution be? Final color of each experiment. Will iodine be displaced? Yes, you form iodine, right? Iodine, brown iodine, you should know what. Aqueous iodine is brown. Think about test for starch. Do you learn your test for starch for bio? Yes, right. Iodine turns from brown to blue-black. That means normally aqueous iodine is what color? Brown, lah. That's why you test for starch will turn blue-black, ma. Brown to blue-black, ma. Okay, so aqueous iodine is actually brown in color. Understand? Okay, but anyway, so answer is brown. 29 to 31. 29 to 31. No? 32 to 33. 32. So they say already X belongs to group 3. Just to let you know, group 3 is just group 13. Okay, you just write on top 13. Group 6, Roman number 6 is group 16. You just write on top Roman number 16. What will be the chemical formula of X and Z? Do you agree this one is a metal, one is a non-metal? So what kind of bonding?
Covalent.
Oh, metal and non-metal. Ionic. So X is what charge? If it belongs to group 13.
3.
So X is 3 plus. Not 3. Don't tell me 3, Then your Z belongs to group 6, so it's like oxygen. What charge?
2 plus.
2 plus. How many valence electrons? Again, use the logic. A. Group 16 is what?
Oh, wait.
Yeah, what you say?
2 minus.
2 minus. So lowest common multiple is what? Between 2 and 3.
6.
So how do I make this 6? X
Times 2.
2 Z
3.
yellow. Okay. Think about what is the charge. What kind of bonding worse than what kind of charge? 33? No. 34 to 35? No. 36 to 38. And let me show you, no need to go through 36.
Wait, titanium is
You don't know, but you can decipher from the formula of titanium oxide.
oh, one nitrate is just minus.
Yeah, correct. 37 to 39. 40. Okay. Now, today, so put it aside. I give out another assignment paper already. Okay, so please complete them by next week. So this actually trains your understanding for the topic. Okay, but anyway, let's continue. I want to do revision on acids and bases today. Okay, now, I just want to go through the main things. You revise on your syllabus. Acids. Let's start with acids first. We have both strong acids and weak acids. Okay, for strong and weak acids, let's see. Anna, do you know what's the main difference between your strong and weak acids? Definition of strong acids is what, dear?
When it's dissolved in water,
Uh-huh.
then associates
Uh-huh.
completely to produce H plus ions at a high concentration.
So dissociates completely, right? In water, you're right. Okay, so this one on the other hand dissociates what?
Partially.
Partially in water. So know the completely and partially in water. For just now you also mentioned the other main thing between them is this one, strong acids, okay? They actually ionize to form high concentration of H plus ions. This one on the other hand, ionize. Ionize is the same as dissociate, okay? To form low concentration of H plus. Another main difference between them, you should know already, rate of reaction between your strong acids usually is faster, whereas your rate of reaction for weak acids usually is slower. But sometimes for strong acids and weak acids, okay, since we are talking about rate, okay, later we'll see, we have dibasic and monobasic acid, right? Dibasic and monobasic acid will also differ. So later we'll go through the one with, let's say, you're this sulfuric acid and you're this hydrochloric acid. But the last one we need to take note is the electrical conductivity. Adam, which one is actually a better electrical conductor?
The strong acid.
Yes, okay, conduct electricity better. Because why? Explain.
Because
It has
it has a complete ionization.
so does it explain?
So
You're missing keywords. Complete ionization means you have
means you have the
more
mobile ions,
more or fewer.
more mobile ions.
Free to move, to
They
conduct.
conduct electricity.
Very good. Okay, so now let's go through strong acids and weak acids. The strong acids in your syllabus to know, we have two types, the monobasic acids as well as my dibasic acid. So the monobasic acid in my syllabus is what, Anna? What's the monobasic acids that you learn that are strong? They are high
HCl.
HCl. HCl, notice how why monobasic. Do you know what's the meaning of mono? Mono means what? Di means what? Mono means two.
3,
Mono means one.
1,
One. Di then
2.
Oh yeah. Okay. So do you know what mono means? Every 1 mole of acid will dissociate to form how many moles of H plus?
1.
1. That's why it's called monobasic. Again, nitric acid is also another one. Please know the formula. Will ionize to form 1 mole of H plus. The dibasic acid, for example, the sulfuric acid, will ionize to form how many moles, Anna? 2 moles of H plus. And then SO4 2 minus. Now, so let's go through. I want to talk about one thing, is your acid reaction. You know all your acids reaction already, right? So let's try brief one. First one, Adam, can you tell me acids can react with what?
Metal,
To form?
salt, hydrogen.
Salt and hydrogen gas. My question is it all metals?
No.
Not all metals, but what kind of metals? That cannot react? Tell me all the metals in the periodic table that cannot react.
Silver, gold, platinum, mercury,
And copper.
copper.
Yes. Okay, the inverted T. Alright. Next one, Anna, tell me another reaction acids can undergo.
Base plus acid.
So acid plus base is also known as what kind of reaction? Type N
Neutralization.
will form what?
Salt plus water.
Very good. Next one, Adam, what can you tell me what's the last one? Acid can
plus
react.
carbonate, salt plus water plus CO2.
Very good. Okay. So, question Adam, what's the test for CO2?
Bubble into lime water, then there will be the
White.
white precipitate.
What's the white PPT chemical formula?
CaCl.
No.
Wait, no, CaCO3.
Yes, and then what's the lime water chemical formula? Calcium
CaOH.
hydroxide. Okay? No, not CaOH, CaOH2.
CaOH2.
Okay, now, so again, why I want to talk about this? Because monobasic and dibasic. I'm going to use this as an example. So Adam, you will help me with the first one. So I'm going to have the reaction. This is calculating the volume of hydrogen gas that is produced. When I react a acid and a metal together, the metal I'm going to react is like magnesium. So this is again over time. So I'm going to react, the one in blue is when I have magnesium, limited magnesium, reacting with this excess acid, HCl. We know that you'll form magnesium chloride because salt is always the metal and the anion and hydrogen gas. Now, if I show you this is the one in blue, this is the magnesium reacting with this excess. What happens if I were to have, let's say, magnesium reacting with my excess sulfuric acid? How would the curve look like? So my question is, Adam, will we end up at the same point? So again, now both of them are using same thing, excess acid. So the acid, right, is all in 25 cm cube. 1 mole per dm cube of sulfuric acid, also 25 cm cube, 1 mole per dm cube of hydrochloric acid. And then the magnesium, I'm just using, let's say, 5 grams, 5 grams.
Sulfuric acid is more.
You'll produce more? Higher volumes of hydrogen gas?
Yeah.
That means no. Do you know why? Your answer is wrong. You will produce the same volume of hydrogen gas.
Oh, because magnesium is limiting.
Yes, correct. You will still produce the same volume because I already said this is in excess, right? But what will change?
The rate.
The rate, faster or slower?
Faster.
And rate is always dependent on what? Reflective on?
The number of moles of hydrogen.
Gradient.
Oh.
Gradient. So how will the shape look like? It must look
Sharper.
steeper. Something like this. But end of the same point. This is sulfuric acid. Then the question is why? I gave you before, right? So Anna, just now we learned what is the sulfuric acid. What kind of acid is sulfuric acid?
Dibasic.
Dibasic. Your this hydrochloric acid is what kind of acid?
Monobasic.
So why by saying dibasic and monobasic matters? Because again, why steeper? Why faster rate? Because you have, if a dibasic acid ionized, you will form what? Higher concentration or lower concentration of ions?
Higher.
Higher. If you have higher concentration of ions than the monobasic, will the rate be faster? Yes. Right? Understand? So please take note, dibasic acid is always faster. Adam, can I ask? This time, we know this weak acid. It's an example of weak acid, which is tribasic. I'll use the tribasic weak acid.
Phosphoric.
Yes, phosphoric acid. Notice how we use is always show a reversible arrow to showcase it ionizes partially. If I were to use, let's say Mg, same thing with this excess, okay, phosphoric acid. How would the graph actually look like? By the way, Anna, do you know what would the charge of PO4 be? Can you decipher? Can, right? Because you got 3H plus, so PO4 is what charge?
3.
3 minus, right? This is 2 plus, right? So what's the formula of magnesium phosphate? Can you tell me? Mg3, PO4.
PO4 2.
Very good. And then hydrogen gas. We just need a balance. So again, this is actually my balance equation. So Adam, what will it be if I also have, let's say, 5 grams? The question is, will I still produce the same volume of gas?
Yep.
Why?
Magnesium 5 grams and excess.
No, because the ratio of magnesium, not only is limiting, the ratio of magnesium and hydrogen is still the same. So you always have to compare with hydrogen as well, not only just limiting. So what will the shape look like?
It will be like less
At the same
steep.
point?
Yeah.
Yes, and then less steep, even with hydrochloric acid?
Yeah.
Yes. Explanation, how do you explain in exam?
Because the strength of the acid takes priority over the type
So
of.
how do you write for exam? You don't write strength or exit takes priority. What you say?
Hydrochloric acid
Is
is a
a-
strong acid,
Wow.
while the phosphoric acid is a weak acid.
So strong acid will
So the strong acid will dissociate completely
in
with water
to form high,
higher concentrations of hydrogen ions.
while the weak acid
The weak acid will dissociate partially in water and ionize
to form
lower amounts of hydrogen ions,
Hydrogen
decreasing
ion.
the rate of reaction.
Very good. Okay, now, so this one is what we learned already, right? And now you follow so far? But I want to ask, if I were to change this up, I will just focus on your this magnesium and sulfuric acid. This time, if I change this magnesium, I'm still using sulfuric acid. I'm right here because I don't have space. I use the same calcium, okay? And then I use, let's say, we do step by step. I want to see whether you understand. Calcium this time and excess hydrochloric acid. Because it's also in group 2, this is the chemical equation of the reaction. We are still using 5 grams. I'm not going to change, I'm just going to change the metal. My question is, this is a reaction, you should know equals, okay? Will I actually produce, again, same volume of gas? That's the question. So I already say, this is in excess. So calcium is limiting, right? Agree? So I'm just asking you to compare this with this one in blue. The one in blue. Okay? So my question is, will, the calcium, the reaction with calcium this time, will I produce the same exact volume of gas like how magnesium reacted with hydrochloric acid? Very simple. Usually, what is usually going to affect your this mole ratio? Will mole ratio be affected?
No.
So let's ask Anna, the number of moles we can calculate for here, right? Will the number of moles calculated for the metal be the same as the number of moles of calcium?
Yes.
Really?
Wait, no.
What is the AR of magnesium? You have the periodic table.
24.
24. So you 5 divided by 24 versus this one, what's the AR? Calcium is group 2.
40.
40. 5 divided by 40 and 5 divided by 24, which one will give a smaller number?
The mg.
Really? You type in the calculator 5 divided by 24, what you get? And 5 divided by 40, what you get?
The C.
C is smaller number, right?
Yeah.
So if I have smaller mole, will this hydrogen be smaller?
Yeah.
Because you compare mole ratio is also smaller, right? Agree? Will I then later both of them times 24, will it also give a smaller volume? Yes. So will it be the same volume?
No.
Higher or lower?
Lower.
Lower. So not only that, Adam, can I ask, the rate, because this is now magnesium and calcium, I just changed this up, compare the one in blue. Will the rate be faster than the one in blue or slower than the one in blue? So I repeat, you compare the purple and the blue, okay? We already established you will just end off maybe around here, okay? Lower volume of gas. But will your rate be faster or slower? Because just now we did a bit about reactivity, right? But the reactivity was for group 70. I want you to think outside the box now, So I'm asking you a question, will it be faster or slower? Because you should be able to decipher based on atomic structure. Okay,
You have the periodic table.
here you go. So your calcium is below magnesium.
Okay, and then it's gonna be
Fast,
slower.
slower?
Faster.
Why?
Because the calcium can lose
Electrons?
faster than the magnesium can.
Very good. So, Anna, just to point out, you look at your periodic table group 2. Do you see calcium is below magnesium?
Yes.
So you are further away, right? You just want to lose the 2 electrons, right? You will lose the electrons more readily than magnesium. Means this is actually more reactive than magnesium. Because you can lose electrons more readily, you're further apart. You just need to lose the 2, right? Agree? So, in other words, here your rate will be faster, steeper than this. But it end off lower. So I just want to point out, the one in purple, okay, is the one using your this calcium. So do you see the red I put steeper than the one in blue? Okay, because red should be faster. But do you see volume is lower? Okay, next one. Adam, now your turn. If I use, I know color already. I use orange lah, huh? This time I change it up. Calcium, same thing, I react with the excess sulfuric acid. What will I produce, dude? Calcium
CaSO4.
and hydrogen gas. Can you tell me? I'm still using 5 grams. Okay? This is excess. This is still using the same as this one in red. So I'm comparing the one in orange and the one in red. Will I produce higher or lower volumes of the gas compared to magnesium? Because you see the red graph already, right? So higher or lower?
Still lower.
Still lower, why?
Because calcium is the limiting reactant.
Okay, but how much lower?
It's the same as the
This?
yeah.
No. You wanna know why? So far, right, he's saying,
Oh, because it's 2 HCl. So
no, this is in excess. You see this was excess, you compare the one in blue, the one in red, they managed to have the same volume one, right? That's why you thought that it will be the same volume as the one in purple, right?
yeah.
But I want you to take note, what's the state symbol for all of them right now? Calcium is what state?
Oh, calcium is solid.
Then this,
Equals.
and then this.
Oh, it's gonna be solid.
Yes.
And then it's gonna stop halfway.
Yeah, so again, how are we gonna write? Your state here, it will actually, okay, I don't have space, so I just draw like that. Okay, so again, this is what the graph is. Because, do you see, you will form an insoluble layer around the calcium metal. This is very familiar, right? I went through this, this is also under my this acids and base. If I were to draw this is my calcium added in sulfuric acid. Calcium metal is here. And do you know why calcium sulfate is insoluble? Sulfate is at the top. All sulfates insoluble except for ClB. Okay? So, surface, when they start to react, and they form that layer of calcium sulfate, right? Eventually, can I come in contact between calcium and sulfuric acid? Can but you're blocking what? It's like your wall
Also no.
Cannot. So can they react anymore?
No.
So reaction stop prematurely. This is very similar to I gave you in your notes under acids and base. If you look at your second column, I have the one that is, let's say, lead in this case. Sulfuric acid and lead. Do you see? In the second column of your notes. Please know what second column is. Yeah. Do you see we have the one with your this calcium or lead and sulfuric acid? Then you form an insoluble layer. Idea is that if your product is insoluble, this will actually happen. Because it not necessarily must be lead-2 sulfate. It can be anything that's insoluble salt. Adam, I want to hear the standard answer. How are you going to write the standard answer? Because just now you never mentioned the keyword. An
insoluble
layer of this one?
insoluble salt.
Wait, what is this?
Calcium sulfate
Forms
is
around?
formed around the calcium metal.
And then
It
preventing?
prevents contact between the acid and the metal, therefore causing the reaction to end prematurely.
very good. Okay? Do you want to take a photo here? Now I want to erase already. Take a photo, understand this, you can go back and then do. Everything is color coded. Okay, so I repeat, everything is color coded. Know what the red represents based on the chemical formula. Alright, this is for you to think about that. Because everybody know how to write down your this chemical reaction already between acid and your this base and carbon. Alright? Another reaction we need to take note is your this base, okay, reaction. So when alkaline actually reacts, let's see. So alkaline, right, is base, but I want to point out, base, right, not every alkaline are bases. Not all bases are alkaline. Okay? Alkalines are like what? Your sodium hydroxide, potassium hydroxide. Because alkalines are actually soluble hydroxides or sparse salts. That's why they are alkalines. Make sense? Okay? But do you agree we can have metal oxide that is also a base? Or also insoluble hydroxides, like for example, magnesium hydroxide. Okay? All the insoluble hydroxides are also bases. So please take note. How do I remember metal oxides are always bases? I told you already. All metals will usually form basic oxides. All non-metals form what kind of oxides, Anna? What's the opposite of basic? Acidic oxides. You think about sulfur, chlorine, nitrogen. Are they non-metals?
Yes.
You see they are part of your what? Acids. Okay, clear? So again, the last reaction we need to take note is that base can react with ammonium salt. When base react with ammonium salt, Anna, what's the products form? Salt plus and
water and
a
ammonia.
gas called ammonia gas. What's the test for ammonia gas, Adam?
Turns moisture in litmus paper blue.
And what?
Pungent gas.
Pungent gas. Okay? So these are all the reaction for you to take note about acid and base. Another thing for acid and base is please note this color change in your indicator. So your indicator, do you all see? You are expected to know methyl orange, okay, phenolphthalein, and universal indicator. Please know what is the color change. It's already in your notes for you. Clear? Okay, but I feel that usually for acid and base, please bring this worksheet for salts as well. Oh, can you give me one? Oops, sorry. Okay, pass down. Okay, again, I want each of you to actually try, okay? Adam, do you see we have question 1? You'll be trying question 1. Anna, do you see we have question 2? I want you to try question 2. Oh, you are ready? I also want to do later question 5. So we'll be doing these questions first. So I repeat. Structured question 1 and 2. Please do structured question 1 and 2 first.
Sorry.
Yeah, it's okay. not amounts, concentration. Amounts is wrong. You know why? Moles may be the same.
Yeah.
Okay, so you write concentration will be the right answer. Okay, I cannot accept amounts. Yep, very good. Oh, they ask you two other salts. Why you write sodium hydroxide, sodium oxide? Isn't it with the phosphate?
Oh.
So you think about this. I draw here is the overall equation, but can we actually ionize one hydrogen ion at a time?
Oh.
It's possible, right? So what other possible ions I can have besides phosphate? What's this?
H2.
Let's say I ionize, I lose just one hydrogen ion first. Remaining, you lose one, you left with two, right? So this will be PO4 what charge now if you just lose one plus minus. Then this one can lose.
Oh.
Can also lose one more time, right? So you can also lose, and this time you'll lose one less hydrogen, then this time is PO4 what charge?
Minus.
2 minus. And then finally that's why you can have the PO4 3 minus here. So my question is, what are possible ions I can form with sodium?
Oh.
You see I have this ion, and this ion. All three are all possible, right?
Oh, okay.
So I want you to think about that. Wrong.
So it's any HPO4.
That means any of this, but they already have this one. So you give me these two other. So it's NaH2PO4 or Na2HPO4.
Okay.
Make sense? Okay. So we have here 4. Okay. Very good. Explain why dibasic acid, monobasic acid. Very good. Twice as much. Reaction is faster.
Wait, is dibasic faster or is monobasic?
Just now I draw, right? If you form more concentration ions, think about this. More ions, more possible reaction, faster reaction. Understand? But just now I gave you the tribasic. Even though tribasic is slower, right? Because ultimately it's still a weak acid. So it doesn't really matter. Unless you are both strong, then that's why the strong dibasic acid will be faster than the strong monobasic acid. But do you see that strong monobasic acid is still faster than this? Because this is ultimately a weak acid. What did I say about weak acid? Ionize to form lower H+. Ionize to form higher H+. So ultimately the H+ forms higher concentration than this. Okay? Concentration is slower. The lower concentration. Very good. Okay. Lung form. If I use this, dude, it's not going to be slower than 2 left. 2 is HCl left.
Oh, 2 is HCl, I forgot.
You use sulfuric acid, right? It's not slower than HCl, it's just slower than your disulfuric acid. So your graph should look like this. So this is wrong.
God.
Okay? Next one, as this instead of replace with calcium. Wrong. Hello, write down the chemical equation. I believe you know this. Write down the chemical equation where calcium carbonate reacts with sulfuric acid with state symbols for me. State symbols. Oh yeah, now you know, huh? Okay, so take note. I want to see your this corrections for your salt form. While waiting, please also do question 2 and 5. I will be doing this 3 question, 1, 2, 5. Yeah. But once you're done with your respective questions, let me mark. Yeah.
Yeah, I don't want to explain the last.
Okay, your last one, arrange the reaction, increasing rate of reaction. So will you be able to recognize which is the weak acid and strong acids? So what are the strong acids?
The hydrochloride and the sulfur.
So they are the one that is strongest, right? So would the rate of reaction be faster or slower than ethanoic acid?
Faster.
So you know the one that is slowest already, right? Which is experiment 2, right?
Yeah.
Then followed by experiment what? Between hydrochloric acid and sulfuric acid, which one will be faster?
Sulfur.
Because it's a
Dibasic.
acid. So what is the sequential order? Start out with 2 first, followed by
2, 3, 1.
no 2,
2,
1,
1.
3. You understand?
Yeah.
So how are you going to explain your answer? Tell me why ethanoic acid is the slowest first. Because it's a
Triacetic
weak,
acid.
weak acid, so it will
So it will dissociate.
dissociate.
Dissociate partially in water, ionize to form H+,
Ions in.
low concentration.
That is the full thing. So hence rate of reaction is slower. Then later the other one is to explain sulfuric acid is a
It's a dibasic.
wow.
Wow.
Dibasic strong acid, must write out.
Dibasic strong acid.
Well,
Wow.
Hydrochloric acid.
Hydrochloric acid is strong acid,
That is
monobasic.
monobasic strong acid. So what does it mean? Sulfuric acid can ionize to form
Ionize to form
higher concentration of
H+.
ions. So rate of reaction is fastest. Ionize completely or ionize partially? You never write the Q&A. So you must write completely as well. Okay? And then can I see your corrections, dude? Thank you. Very good. So now you know, mark here. Okay, let's see. Very will you lose a H? You never show me how you lose a H. Like so far everything all lose a H, right? Now you think about this, when Na reacts with HCl, do you see why you form NaCl? Because the Cl minus is the one that makes you react, right? And then if it's like CH3, COOH, because it's a weak acid, right? You lose the H. Where did I say lose from? So what do you think is the N ion? If you compare with that, what do you think is the N ion? What will be the charge?
Minus.
So it's
CH3COOH minus.
why still got H?
Oh, no H.
No H, then it's
Minus.
minus. Do you know what's the formula of magnesium? That one now? Do you have a H? No, right? It's just like how you write NaCl. Do you write NaHCl? No. You understand? Okay? So you realize your reaction also not balanced if you write the H. Okay. Very good. Dissociates completely. Yes. Dissociates partially. Ethanoic acid dissociates partially. No reaction. Can you tell me rate of reaction is the slowest next time? Okay. Then again, monobasic strong acid dissociates completely. Oh wait, you know what? Oh, highest higher concentration. So we relate to rate. Don't just say concentration. So rate of reaction is fastest. Okay? Clear? Fastest rate. Slowest rate. Hey, ethanoic acid is not a tribasic acid. If I only lose one, do you see? So is it?
Monobasic.
Yeah. That's not a point now. Okay. I'll give you time to at least look at question 1 and I'll go through in 7 minutes time. And then if you're done, I can mark for you. I want to go through these 3 questions. Question 1 now, Anna. Look at question 1 first. It doesn't ionize completely.
Partially.
Yeah. At low concentrations. But to be honest, you just tell me in this case, you produce OH minus will do. But because you write the Arrhenius completely, I can't give you the full credit at all. Okay. Yep, correct. Oh, what kind of charge do you think they form? Like, you think about this. If I ask you, because you know ammonium, right? Ammonium sulfate is what charge? NH42SO4. So if I want methyl ammonium, and you already know form plus charge, well, you need 2 of this. With the SO4, because SO4 is 2 minus. They already show you it's plus.
Oh, I can't just add another.
No, you cannot just add another.
Okay.
So it's because it's like. Why you add?
No, I added another hydrogen
no,
there.
no lah. Because the charge is this one.
Oh, so I just have to put 2.
It's just like how the ammonia, if you react with water, by right, you will form ammonium ions. You don't have an NH5, right? Agree?
Okay.
So that's the reason why.
Oh, good. But it could still bond, right?
What? It's an ionic bond. Between the methyl ammonium and the sulfate is an ionic bond.
Wait, but it could still technically form the
No,
NH.
the whole thing is 2.
Oh,
Like there are 2 nitrogen here, what? Later when you write your ammonium sulfate.
okay.
When you write ammonium sulfate is this one. 2.
Okay.
Here, predict the observation when this is slowly added.
I don't know.
Very good, because they already say like ammonium. So this is your QA. You add drop by drop, you get white PBT, dissolve in excess. Alright? Okay? Let's see your number 2. No, it's like magnesium with ethanoic acid. Why do you show me reversible reaction? This is not ionization there, and magnesium is a metal.
Oh, so it's just metal. Wait,
It's just
even,
like
even metal plus weak acid is non-reversible.
reversible also what? Not reversible also what? Yeah, what? Correct.
So it's only acid plus base. Oh, it's only ionization which is
So
reversible.
like for example, your magnesium, you react with hydrochloric acid, you know you'll form magnesium chloride and hydrogen gas.
Yeah.
So if I have magnesium reacting with this same monobasic acid, ethanoic acid, you will form what?
Magnesium.
CH3, COO2, and then H2. Can you see?
Oh, I thought it's reversible.
So no. And then some more your this formula is also wrong. It's 2 of this. See, it's CO minus. You understand? Strong acid ionize completely, produce high concentration H+, ionizes partially, produce low concentration H+. Okay, CH3, you cannot just lose the 2 ions. You thought that you lose the 2 ions, right? But it's not lah, huh? You only can lose on the 1. 2, 1, 3, correct? Weak acid, ionize partially, produce the lowest. Use terminologies because you're comparing with 3. You cannot just say lower. Rate reaction is lowest. Dibasic strong acid. So twice. So rate reaction is the fastest. I always said. If this is actually 3 marks, I only can give you 2. Okay, Anna, can I at least go through? So my goal is to go through question 1, 2, and 5. So let's go through this. So the first one, 1A, everybody knows what is the definition of weak acid. I want to always see this top 2. So these are always the top 2 parts that you must showcase in your definition between the strong and weak acids. Okay? The second thing, I'm not going to go through this, but what I want to go through is your part B. They ask you to write an equation for the ionization of phosphoric acid. If you want to write an equation, this is the equation first. Because this is the overall equation. And it's a tribasic, I want to see 3 moles of H plus form. Another thing I want to point out is, this arrow must be a reversible arrow. If you draw me a straight line arrow, you will be penalized. Understand? Because this is a weak acid. Clear? Next one, they say different sodium salts can be formed by reacting with sodium carbonate and phosphoric acid, other than Na3PO4. what is the other two possible salts? So this one is for you to think outside the box. Again, because this is a weak acid, it doesn't mean all will dissociate all at once. Sometimes they can lose one hydrogen ion at a time. So this is like the overall equation, this is like the step by step. So let's say your phosphoric acid, just lose one hydrogen ion. Hydrogen ion is H+, right? So this one is one less hydrogen. The overall charge, Anna, do you know why it's minus? Because you lose one H+. So you are now minus, right? And then this one H2PO4 got enough hydrogens to still ionize? Yes. There's still hydrogen ions to ionize. You lose one H+, this minus will now become 2 minus. You understand? So, and then we can also lose another, then become 3 minus. So do you see these are the 3 anions possible? So what are the salts I can form? The sodium can react with this to form Na3PO4, but they don't want this. But do you agree sodium can also react with this? Since it's 2 minus, you need 2 sodium. This is the other salt I can form. Because it's 2 minus, that's why you need 2 of Na. And then this is a minus, so that's why NaH2PO4. So answer is this 2 for part C. Write down. Quick. Now this one for part D I already went through with you. Whenever you're ready, and Anna, can you read out your answer whenever you are ready? Do you know why? Go back and revise. Okay? You can do the, oh, you're right? So Adam, if you're fast enough, you can do the homework, so you have lesser homework to do. The MCQ. Okay? Ooh, careful. Okay, and now whenever you're ready, what curve is your answer?
You go to
Yeah, go ahead. HCl is what curve? Whenever you're ready. And now you just write down this, what is this for part C? Because they say just suggest the formula.
Yeah. I want to write the whole
Oh, okay. Can. Okay, again for part D, answer, what's your answer?
Is it 213?
Correct. Answer is 213. Okay, for D part 1. For part 2, can you actually start this? The answer will be exactly the same as 2C later on, so I'll just give this once. Again, this is usually 3 marks, just write the 3 bullet points. First one, can you write? The ethanoic acid, the phosphoric acid, H3PO4. H3PO4 is the weak acid, hence is the only acid that ionizes partially in water, is the only acid that ionizes partially in water to form, because there's a comparison of 3, to form the lowest concentration of H+. To form the lowest concentration of H+. Okay? So, comma, rate is the slowest.
So ionize to form H+ ions. Then
So, lowest concentration of H+. You must say it's the lowest out of the 3. Hence, rate is the slowest. Underline. Underline, ionize partially. Underline, lowest concentration of H+. Underline, slowest. Great. Second bullet point, you now need to compare between sulfuric acid and hydrochloric acid. Write down. Second bullet point, there's always the 3 bullet points you write for exam. So you write sulfuric acid, always compare the greatest. Sulfuric acid is a strong dibasic acid. sulfuric acid is a strong dibasic acid, while hydrochloric acid is a strong monobasic acid. Is a strong monobasic acid. Third bullet point, write down. Sulfuric acid will ionize completely to form highest concentration of H+. Will ionize completely to form highest concentration of H+. Hence, rate is the fastest. Highest concentration of H+, hence rate is the fastest. Underline dibasic, underline monobasic. Underline ionize completely in water. Underline highest concentration. Underline ionize completely in water. Underline highest concentration and fastest. Okay, next one. They ask you to come up with a chemical equation. Both of you are wrong, so I just want to point out. Chemical equation is this one here. Because you should know the CH3 COH is a monobasic acid. This is what they ionize. This is the equation you write for question 8. Forgot to mention about part C. Okay, I forgot to do part C. Part E, my bad. Let's do part E. Anyway, let me draw on the board. So part E, yeah. On the board, we have your 1, 2, 3, right? I'll just write down. This one is for this sulfuric acid, hydrochloric acid, phosphoric acid, which we already established. But now, do you see they are going to have your mass of sodium carbonate added to sulfuric acid, but it's double amounts of double amounts of sodium carbonate. If I have more sodium carbonate, do you agree amount will actually be more? I repeat, you want sodium carbonate, more sodium carbonate added. Sodium carbonate when I react with sulfuric acid. This is a chemical equation that I form. Okay? Now, this is limiting as what we can see, because you can see how the total amount of acid produced is the same. Now this one I times 2. If I increase by 2 times, the number of moles of this will also increase by 2 times, right, Anna? What will happen to the number of moles of carbon dioxide? Will it increase or decrease? Increase. Also, right? Agree? So that's why you will have a higher volume of gas produced, right? Agree? But the question is, this is reacting with sulfuric acid, and they say this sodium carbonate is now in lumps. Lumps is lumps. The surface area, do you think is higher or lower?
Lower.
Lower. So the rate will be faster or slower?
Slower.
So it will actually be slower than sulfuric acid, but still faster than hydrochloric acid. Your graph should look something like this. You can label this as number 4. Next one. Notice how? For number 4. Notice how they want to replace sodium carbonate with this calcium carbonate. Calcium carbonate looks like this. You will give me my state symbols, Anna. I will form calcium sulfate, carbon dioxide, and water. So calcium carbonate is what state? Think about it, whether soluble or insoluble, because it's soluble obviously. All carbonates. You know where carbonates in the 5 circles? Top, bottom, left, or right? Right, right? Soluble or insoluble? Except for spa.
Soluble. Wait, insoluble.
Except for spa. So this is what?
This is
If it's insoluble?
insoluble, so it's solid.
Yes. Next one. Sulfates is at the top, right? All sulfates soluble or insoluble?
Soluble.
Except for the lower grade Chinese. CLB stands for
Calcium,
lead and
lead, and barium.
So is this soluble or insoluble?
Insoluble.
So it's solid.
Solid.
This is gas, this is liquid. You see an insoluble layer can form around calcium carbonate. What happens to reaction? It will stop prematurely, right? So what will the graph look like? So with sulfuric acid, you will realize this is the graph. This is number 5.
Wait, why is CaSO4 solid? Like, why is CaSO4 solid?
It's insoluble. You just said what? All sulfate soluble except for calcium sulfate, lead-2 sulfate, and your barium sulfate. Insoluble, is it solid?
Yeah.
That's why cannot dissolve ma. That's why I cannot write AQ ma.
Then what about the sulfate? I mean the SO4. Because I thought SO4 is soluble, so
Except for, you know what is except?
except for the
Calcium sulfate, except for lead-2 sulfate, except for barium sulfate. When I say except, that means are they soluble? They are insoluble. Understand? Know what I'm meaning of except. Anyway, for 2A, they ask you to write a chemical equation for magnesium ethanoate. For 2A, answer is already here on the board. Okay, make sure you have this. So they already say what strong acid, weak acid. I'm not going to go through because I already said it's this top 2. Answers for part C is the exact same as your template for 1D part 2. You just need to replace phosphoric acid with ethanoic acid. Understand? Okay? So just need to take note. Answer for 2C, exactly the same template as 1D. You just need to change phosphoric acid to ethanoic acid. Okay, I want to look at question 5. All those you can start to see is all application questions. Now in question 5, they now say, I have a new kind of base. Methylamine, and they say methylamine has properties of what, Anna? Similar properties of what?
ammonia.
Ammonia is like a weak base, right?
Yeah.
Okay. So in other words, we can use that logic. They show you the reaction. They ask you to explain why it behaves as a base. Why is the ion always relevant to a base? Why is the ion always related to a base? Like acid is always H plus, right? Base is always
OH.
minus. Okay, so is this going to show you a base? Look at the equation they have.
Yes.
So how are you going to explain why it behaves as a base? Because you will what?
Produces
Ionize, dissociates in water to form what?
to form OH.
Minus. That is the definition why it behaves as a base. As long as you tell me it will dissociate in water to form OH minus, I will give you the marks because that is what we always look out for. Next one, dot and cross diagram of CH3 and H2. Let's try. And CH and N, are they metals or non-metals?
Wait, is it ionized to form OH? OH minus ions.
Is it? To be a base?
4, 5.
I want you to use your logic. Is it?
Wait,
Is
it's
it?
not ions, right?
Their ions are always minus. You have a charge of 1 minus. Are you an ion?
Yes.
Yes. Okay. Okay. Next one. Again, CH and N, are they metals or non-metals? Because you need to draw the dot and cross diagram. Metals or non-metals?
Non-metal.
Non-metals. So again, if they are non-metals, that means what kind of bonding? Covalent or ionic?
Covalent.
Covalent. Carbon is a central atom. Do you agree? Any of most, right? Then because they already say CH3, your H will look at the side of carbon. And then they say NH2. So the N is beside here, and then we have 2H. I say draw first, right? Then after that, do I care about the central atom yet? So what do we care about? Hydrogen. Hydrogen you need how many for noble gas?
1.
1. So we share 1 pair. Okay? Share 1 pair. Share 1 pair. Same with this here. I make nitrogen as a big circle. Later we can take note. Next one. Do you see this bond pair we also must share? Carbon must always share how many electrons? Group 14, so must share. How many valence does it have? 4. So far only share 3, right? 3 dots. So must share how many more? 1 more. So nitrogen also, question, in group 15, 5 valence electron. In need how many? Share 3. So far you see how many circles they share? 2. So need to share how many more? That's why each one of them share 1 more pair. Okay? After that, draw the valence electron of hydrogen. Hydrogen, all valence electron drawn already, right? Nitrogen is in group 15. How many valence electron? 5. How many circles you see so far?
6.
Huh? Circles, not dots.
3.
3 circles. So how many do I need to draw more?
2.
So 1, 2. Then after that, carbon, group 14. How many valence?
4.
So do you see 4 dots already?
Yeah.
Because the cross belong to hydrogen, the dots belong to carbon, the circle belong to nitrogen. This is the dot cross. Whenever you're ready, I want you to look at part C. Okay, in part C, right, they already say that methylamine is properties of ammonia. Now, if I use ammonia, do you agree this is what we have? You form this ion called ammonium ion. Ammonia can react with sulfate, right? Sulfuric acid. Then if I form ammonium sulfate, can you tell me what's the formula for ammonium sulfate first? Because sulfate is what charge?
Sulfate is 2. SO4 2
2 minus. This is NH4 plus. So what's the formula for ammonium sulfate?
NH4 2 SO4.
Okay, but now they give me was the methyl ammonium sulfate. Did they show me what methyl ammonium sulfate, the methyl ammonium looks like? Because you see where I get the ammonium from here, right? Do I know what methyl ammonium sulfate?
CH3NO2.
So CH3NO2. Really? You want to see again at the top? Do you see this equation I write here is very similar to the equation at the top?
Yeah.
So what will be the methyl ammonium formula? Because I know the ammonium formula you say NH4 plus because from here, right?
CH3NO NH3.
NH3, you sure? You look at the ion.
NH4.
Do you write NH4? You open your eyes and see carefully. NH what?
NH.
Hello. Do you see this equation? Similar pattern to the equation at the top or not? Not similar, man. Why are you flipping?
Oh, I didn't write it.
No, it's not there. It's already in the note, in the worksheet. Do you see the equation of methyl ammonium?
Yeah.
Do you see similar pattern with this?
Yeah.
How come I know this is the ammonium? That's why I know how to form ammonium sulfate. Do you know how to form the methyl ammonium?
Plus.
So what? So it's CH3NH what?
NH2.
2 what?
2.
Plus, right?
Yeah.
Do you need to memorize or not? No need what? It's just logic what? You see. That's why I come out here what? Do you know now what sulfate is? SO4?
2 minus.
Will you know how to come up with the formula of methyl ammonium sulfate?
Yeah.
So it's what?
CH3 NH2 2SO4.
Yes, this is the answer. Understand? So you can follow the pattern because you know ammonium. And they already say it's like properties of ammonia. This is the chemical formula. Just write this. Okay? Okay, now when they say when aqueous methylamine, amine is slowly added until access to a test tube containing aqueous iron 3 nitrate. Reddish brown PBT is C. Straight away you see reddish brown is under which chapter?
Qualitative
Analysis. Yes, next one. They say predict the observations you expect to see when you add aqueous methyl amine slowly until excess to separate test tube containing zinc sulfate. Now, but we do not know anything about methyl amine, but we know something about ammonia, right? If I throw back the question to you, if I add drop by drop of ammonia, aqueous ammonia, to zinc 2 plus ions, what will you see? What color is this? White
White
PPT, right? Of zinc what? Is always a high drop.
hydroxide.
So you will form zinc hydroxide, right? Is the hydroxide soluble or insoluble in excess aqueous ammonia for zinc? You remember I asked you to star the zinc because it's special?
It's soluble.
Yes. So in other words, we will form a white PPT with aqueous ammonia, and then the PPT is soluble in excess, right? They already say methyl amine has same properties as ammonia. So if this time I add methyl amine to aqueous zinc 2 plus ions, what will you first see? Will you have similar reactions with ammonia? Yes, right? Because they already say similar properties to ammonia. Do you look at the top?
Yeah.
So what can we write? We will first form a what color PPT?
White.
White PPT, which is soluble or insoluble in excess.
Soluble.
So how do you write for exam? Which will dissolve in excess
Dissolve in excess.
methyl amine, like aqueous ammonia, right?
Yeah.
To form a what? Color?
Colorless solution.
Yes, same exact thing. So you say a white PPT forms, which will dissolve in excess. Okay, methyl amine to form a color solution. That's why please learn how to apply. Okay, Adam, can we now go back so we can practice more? So these are the type of typical questions that applicational wise you can test for acids and bases. But now the fastest way to, do I need to repeat? To form a color solution. Flip to the front where you see the MCQs because I feel I need you all to do. So if you do not know, I can go through on the spot. Let's start out with the first one. No need you do one first. You do the selective questions I want you to do. I want you all to do from question 2 to 11 first. 2 to 11. We do step by step. I repeat, question 2 to 11 first. You'll go through. Again, if you're fast enough, go and try the homework first while waiting. I just want to point out, I say poorer but doesn't mean cannot conduct, can still conduct electricity. Yeah. How's your competition? You say you finished your. Have you finished your competition already? Oh, how is it? Not very good. Oh dear. That is what, B division? Oh, okay. Okay. And now which question are you at, dear?
10.
Okay. Once you're done, let me know. Then I can give out the answer. The last you mentioned, you said your teacher was a QA, right? Have you finished gas? Test for gas as well? May I know what's the next topic your school going to go through, Adam? Let me know if you have them.
We didn't get the term 3 notes yet.
Okay. But the last was QA Did they touch on gas?
Check.
Okay, done.
Okay. Can you help me mark plus? I will go through now. Any questions and I'll go through and do next week. 2 Bombay, sorry. 2 Bombay, 3 Australia, 4 Denmark, 5 Denmark, 6 Canada, 7 Bombay, 8 Bombay, 9 Bombay, 10 Australia, 11 Denmark. Okay, let's see because all this critical thinking question. 3 to 4, anybody need me to go through 3 to 4? 4. So 4 is about, again, the number of moles. But they say you want to give a neutral solution, right? If I want to give a neutral solution, that means there's nothing in excess. Agree? So we need to see, if I were to have my chemical equation, sulfuric acid will actually react with 2 moles of sodium hydroxide. Acid and base gives you salt, which is sodium sulfate, and water. They already say I'm provided with this 20 cm cube of 0.5 moles per dm cube of sulfuric acid. We just need to make sure the number of moles of sodium hydroxide is exactly twice the moles of this. So let's calculate the number of moles of sulfuric acid first.
The last topic was preparation of salts.
Okay, thank you. Okay, so again this will be 0.01 moles. So to have complete neutralization, that means nothing in excess. Do you agree we need again the number of moles of NaOH? The idea is for complete neutralization. Must be how much, Anna? Look at the ratio.
2 is
1 is to 2, right? So if I have 0.01 moles of this, how many moles of NaOH must I have?
2 times 2.
So 0.02 moles. Now let's calculate. It's just times, right? 0.02 times 0.5, does it give you 0.02 moles? No, so A is wrong. 0.01 times 0.5 will give you 0.005. So it's also wrong, right? Next one, 40, 0.04 times 1 is 0.04. Does it give you 0.02? No, only one is D because 0.02 times 1 is 0.02. Okay? 5 to 7, anybody?
6.
6. A gas mixture containing hydrogen, carbon dioxide, hydrogen chloride, and ammonia will mix. They pass through liquids in the order. Do you agree? Again, your hydrogen is actually neutral, okay? But hydrogen chloride, when dissolved in water, become hydrochloric acid. Ammonia dissolved in water will become ammonia, aqueous ammonia. So it's acid and basic properties. So again, they say the only gas pass through all liquids are what? Hydrogen. Do you know why? Because carbon dioxide is an acidic oxide. Will it also get neutralized in sodium hydroxide as an acid and base reaction? So hydrogen is the only one neutral. Okay, so I repeat, carbon dioxide dissolved in water is acidic. It will be gone by sodium hydroxide, neutralized. And then this hydrogen chloride will gone and neutralized by sodium hydroxide as well. Ammonia will be gone and neutralized by your hydrochloric acid. So the only answer is hydrogen. Okay, 7 to 9, 7 to 9. No. 10 to 11, 10 to 11. 11. They say some properties in an unidentified substance are listed as follows. Its aqueous solution has a pH of less than 7. So we already know it's acidic. Straight away, we cannot choose B. Because B and C are not acids. Hopefully you know the COOH is very similar to the ethanoic acid. So far A and D is correct. Next one, it reacts with zinc oxide to give you salt and water. Sure. It reacts with sodium carbonate to give you carbon dioxide. Yes, means it must be an acid as well, right? And then they say react with magnesium to form magnesium hydroxide, but it burns in air to give water and carbon dioxide only. Do you agree hydrogen chloride cannot give you water and carbon dioxide when there is a chlorine? Where's the carbon coming from? That means HCl, you think about this, if you want to burn in oxygen, that means in air, you at least form water if you got this, or again ClO2. Where's the carbon? There's no carbon to give carbon dioxide. You understand? So that's why it's impossible to be A. Answer only will be D, because you see D only have carbon, hydrogen, oxygen. Potentially can give you the elements of the product. Okay? Now, again, I think I want to do the rest, okay, when I see you next week. Please bring this worksheet, okay, for class next week. Homework is actually the paper that I give out. Anna, if you can, right, can you go back and try the MCQs first? Okay? You go back and try, alright, the MCQs. Adam, for you, I want you to do later in class next week. Alright? I think today I'll just end off here. One thing I just want to emphasize is know what's your acids and base. You learn today we compare between your acids like monobasic and dibasic, alright? Agree? And we also compare, sometimes they give you another base that you've never seen before, but you can simulate what we've learned. Alright? And with that, I end off here today. Okay? Clear? Alright, anyway, please sign before you leave. Sayonara.